So I usually start off my talks with questions to the audience that are not particularly informative for anyone, but it gets us engaged. So who here had an application crash once in their life? Who hasn't? Okay, Tobias, which one has not crashed?
All of them.
All of them. Perfect. So yeah, crashing is like a thing, right? We have to deal with it. But before we get to that, let me tell you about me, because I'm important. I have the microphone, so I must be. So I'm a KDE developer for like 20 years, more than that actually. I've been around forever. Currently I work for Tech Paladin. We do KDE consulting. And I work on KDE Linux and Plasma and frameworks and all the things really. And I'm also a crash report connoisseur. I do rather enjoy crash reports, in particularly the ones that have something misspelled. So for example, a very good one is always my application crashed. So how can you crash, right? How can you crash? You can crash poorly or nicely. What do I mean by that? Well, poorly is your application encounters an error, terminates. No user visible signs of anything. This is horrible. We don't want this, right? What, does anyone want this? No? Well, good for you. I also know how to do it nicely. So we terminate the process, but then we help the user help us, right? What do I mean by that? A bug report would be very, very useful. A crash report would be even more amazing. What's the difference, you ask? Well, a crash report is obviously about the crash and not the bug. So when we talk about crash reports, we actually have to look at how do I even crash, right? How do I handle a crash? And there are two sort of broad concepts in play here. There's just in time, and then there's post-mortem. Just in time, as the name suggests, is you catch the crash just in time before your application goes whoa. Instead, you get a segfault, or like the kernel gets a segfault and invokes a signal handler. Then you do some stuff, possibly fork a helper binary. And then you diagnose the application and report the issue to somewhere. This has a bunch of problems. For example, racing threads. Now, I was lying a bit earlier. Well, I omitted a very important fact. The signal handler runs in a thread. Now, I'm sure we all have multi-threaded applications, right? Like, that's just the nature of the beast these days. We have like dbus threads and UI threads and logic threads and file system threads and all the threads, right? But only one of them gets the signal handler call for, hello, there was a seg fault. Problem is, what are the other crashes threads doing? Anyone? I guess?
All the things.
All the things. That is quite right. Yes, so that's why we have racing threads, right? So while we are handling the crash, the world keeps moving on and things become a bit horrible. So racing threads, not good. Just-in-time debugging has a lot of them. Then we have locked resources. For example, open file descriptor. This is a surprisingly huge issue. For example, like the way dbus knows that your application has gone away is because the socket gets closed. And if you are busy handling the crash, then your socket is still open and nothing else can talk to you, but you're also not quite there. So it's like you call someone and they are not picking up, right? And horrible. So it's also poorly reliable because of a combination of all of these facts, right? So if your threads keep on running, then they are in a random state when you report whatever happened. So no great surprise, I don't like just-in-time crash handling, I like post-mortem crash handling. This also has a number of other names like tombstone crash handling or like, yeah, a bunch of them. The idea is more or less the same, right? So you get a seg fault, the signal handler gets invoked. Eventually, you go like, well, we don't actually want to handle this signal, defer it to the default signal handler. The kernel goes, this signal has gone unhandled. What will I do? We'll do a core dump. And then the rest of the stuff happens separately. We'll brush over this for now, mostly because it's boring, but we'll come to it in a moment. So slight intermission at this point. What is a core pattern? So I said here the kernel does some kernel handling or invokes a handler. And for that we need the core pattern. Now the core pattern is, I think we need to go way, way, way back. Who remembers core files? Perfect. You're all old? No, it's fine. So like way, way, way back in the past, the solution to a crash was the kernel would take a memory dump of your process, put it somewhere on disk, and then that would be your record of the crash, which is, a solution. But also, then you have random files appearing on the user's system, which makes absolutely no sense. I vividly remember the first time that I used Linux. Well, in the first weeks anyway, I was using some beta release of some SUSE version, and it was very crashy, and my home folder kept accumulating all these randomly named files, and I was like, what is going on here? And so the core pattern is sort of the solution to that, is you can attach meaning to these files. But more than that, you can also invoke a core handler. So if you like, let's see. So if you check out your core pattern, it probably looks something like this. And it starts with a pipe, which is insofar interesting as this pipe denotes that this is going to be an invocation. So it's going to run systemd core dump to collect this crash rather than dumping it on file, which is a step up. And this is actually going to be the cornerstone of how we do crash handling in KDE Plasma. Well, it is already today, but I'm telling you about it now. So here we are. But post-mortem crash handling also has a bunch of problems. So that's the presentation.
Already, right?
There we are. So post-mortem is not nearly as flexible as just-in-time. With just-in-time, the process is frozen. Well, it's not frozen, but it's there in some sort of state that you can possibly probe, right? So you can invoke functions and look at all the variables and all the stuff. With a post-mortem crash handling, you can't necessarily do that because all you have is the memory dump of the process rather than the full running process. And the other problem is, and it's either a problem or it's an advantage. I'm going to say it's an advantage, but I've listed it here for completion, which is it makes crashing a platform concern. So instead of you, the application developer, going, I'm receiving a seg fault signal, and now I'm going to do crash handling on this. Instead of that, we defer it to the kernel, and then the kernel does things. And so you give away control there. So how to crash nicely then, right? I'm going to show you the KDE Plasma way. And if I've learned one thing this weekend, is that we need to have live demos, which is all the more exciting if you have a live demo that involves crashing things. And possibly also talking to servers to submit things, and then again talking to other servers to retrieve things. So this is going to be very, very interesting. So what shall we start off with? Well, any ideas?
Your terminal has ideas.
Yes, but that was a terrible idea. So let's start easy. So in KDE Plasma we have a separation between compositor and the shell. So the shell is just the wallpaper and the panel and the stuff, the applets and the systrain, and the compositor just does the compositing. So I can kill Plasma Shell, hopefully nothing will explode, but it will definitely crash, right? So here we go. Suspense, suspense. Give it a moment. It's gonna be fine. Here we are. Plasma Shell is closed unexpectedly. And it started again. So that's one of the clues of how to crash nicely, right? You want to start the film. But now we have a crash handler. So the crash handler now gives us the opportunity to send an automatic report or see developer information. We look at developer information, and here we will get a backtrace at some point. And you see, like, there are a buttload of threads involved in the shell, so having these racing threads in just-in-time debugging would be a real problem here, because as the file descriptors may be in any state, the threads also may be crashing on file descriptors, which is actually something that happened for quite a while in file notification, I want to say, in the glib thread for iNotify, where it just stumbled over a closed file descriptor and boom, suddenly your crash is no longer useful. Now, here we can go, well, we want to report this to bugs.kde.org, and then we get a nice dialogue of like, yeah, so do I remember what happened? And yeah, it crashes all the time because I'm running. Kill always stack fault, obviously, right? And then again, so your crash, the backtrace for inspection. Then it's talking to Bugzilla, it logs me in. Then you notice a tiny bug, but I make it disappear. And then you type like, well, what? Right? Your bug report. And this then ends up as an actual bug report with the crash data attached. I'm not going to do this because I don't want to spam our Bugzilla instance with a pointless bug report. But you can believe me that this is eventually going to end up on KDE's Bugzilla, and with the backtrace attached, the backtrace inline, so you can nicely search for it, and a bunch of metadata about the system, so like the version of the operating system, where did the binaries come from, that sort of thing. Now, I have to tell you about this application. This is called Crashinator. It is my go-to application for testing crashes, right? So it has like all the ways to crash things. You can crash it, then you can crash it from the GUI thread. You can crash two threads at the same time. You can also have like hang the application for a while or exhaust all the FDs, all the options of crashing I have at my disposal. And if I crash the application, then this is the standard experience that you get. If you don't crash your shell, you will just get a notification. Something has crashed, and then you can choose to restart the application. And there it is again. But at this point in time, I want to do the really dangerous thing that we saw earlier, right? So what if my compositor goes away? Quinn Wayland, obviously. Any bets on what's gonna happen? Because I'm not sure myself. So
LibreOffice is gonna crash.
LibreOffice is gonna crash. That's probably a good one, yeah. Let's see. Maybe everything goes away. Oh, what happened here?
LibreOffice crashed.
LibreOffice crashed.
The rest didn't.
The rest didn't. Interesting. Interesting. So if I go back to my presentation, let's close the code. Let this go away. I still have my presentation open and everything, which is interesting, isn't it? And that's actually because of magic created by David Edmondson, one of the lead Plasma developers, who figured out how to make applications not go belly up if the compositor briefly dies. And there's actually patches for GTK as well, but they have not been accepted, so poor LibreOffice, I guess. So at this point, you will notice that there's an auth dialog that seems a bit contextless. It's contextless because Quinn crashed and nothing was there anymore, right? And Quinn is a privileged process. It's not rootful, but it's privileged. And so it doesn't let you just create a core dump of it, but you need to actually authenticate that you are allowed to access this core dump. And then it's the same workflow again, right? So you can create your trace, which is also going to take forever here. And you can do your bug report once the trace is complete and all this stuff. So it's the same workflow for an application as it is for the compositor itself. And I think that's already very nice. What else can we do? Okay, so let's do crashinator one more time because I want to. So let's crash, I don't know, from pure now, because why not? So I have somewhat skipped this first option, right? And being the first option, this is probably the preferred option. Send an automatic report. And so one of the things that I've learned over the years is that people are very, very quickly annoyed with a workflow. And so when your application crashes, you're already annoyed, right? You do not want to add annoyment to this, so that's why we have the send automatic report option, which does just that. If I click it, it's going to send an automatic report. Now this is crashinator, so obviously I'm fine with doing that because it's its purpose. And it has sent a crash report. That's all. It's done. You can close the window. But obviously you don't believe me. Do you, Lydia?
I do.
No, you don't.
Okay.
So this is the part where we talk to the server. That is also not very fast. But hopefully it will have processed the data already. Ah, it has. Well, which brings us to the next topic. Crashing is one thing. Getting the data and then doing something with that is another thing. And for that we have a crash reporting system called Sentry. It's not made by us, but it's used by us. And we basically, when you send an automatic report, it always ends up in this crash reporting system. And here we have like random crashes for stuff. And up here is the one I submitted that I cannot get to. Ooh. And so here we see. This crash appeared first 2 minutes ago, because I submitted it 2 minutes ago. We can see that it was crashinator that crashed. We see that it received signal 11. We get the stack trace. Let's actually look at the entire stack trace. So there's like all the JavaScript and indirection and object management stuff. And then up here is somewhere the actual crashing function. And we also send a bunch of extra metadata along with it. So like, what was the crash handler, what was like the operating system that this crashed on, graphics information. So like for Quinn in particular, we collect information on which graphics driver I believe we use, so we can actually identify driver bugs more reliably. And yeah, so a whole bunch of metadata. And this is our crash tracking system. And as you saw, it's very neatly integrated, right? Everyone on board? Amazing, right?
Yes.
Very good. Nodding heads. Let's move on. So these are like the backups in case. So
In case it didn't crash.
in case it exploded horribly, but it didn't. So hooray! We survived a compositor restart. That was good. But yeah, so we have like the crash handler, and we do have a notification when the application crashes, and we can look at the backtrace. If you're a developer, obviously this is where it ends, right? You look at the backtrace, go like, well, obviously I forgot the semicolon, not a semicolon this one. Obviously I did reference the null pointer, the obvious mistake, and that's where it ends. For the user, they would usually go through the automatic bug report and submit it that way. And obviously, if you are a user, an advanced user, so like in the in-between area where you sort of know what you're doing and you're comfortable with logging in on Bugzilla and that stuff, then you can obviously also still use the regular workflow with submitting to Bugzilla. Okay, so how do you crash nicely? Well, it starts with the set fault, the little mouse. And then comes the signal handler, the trap with the cheese. This is not going to continue, don't worry. So, if it is a KDE application, then K-Crash is going to be our framework of choice. This is going to create the signal handler for us, does collect a bunch of metadata, and stores it somewhere safely so we can retrieve it later, and then it invokes the kernel, and then we have a core dump. Woohoo! Kernel takes over, kernel calls the core handler. The core handler is usually core dumpd. Any interjections on this being core dumpd? What about Ubuntu, you might say? What about Fedora, you might say? You didn't, so I'm doing it. But indeed, so at this point, we again need to take a bit of a detour, because obviously at this point, there could be something else. So up to here, this is platform concern. This is, I'm gonna implicitly tell the kernel, I've crashed, do something. The kernel looks at the core handler. The core handler, in most instances, is core dump d, like I've shown you, like on my system. But on Ubuntu, it is apport or whoopsie, I don't know, some silly name. on Fedora, it is abrt, and they're basically doing the same things that we're doing here, but for their specific platform. So at that point, you can forget all about what I'm going to tell you next, because it's not applicable. So core dump d collects more metadata, puts it into the journal, and then we need something to react to the journal data. And this is where this lovely dialogue came in. It's called Dr. Conky because it diagnoses your issues and does absolutely nothing to fix them. I don't know why it's called Dr. Conky, but Nate Graham, a good friend, always complains about it being called a doctor when it doesn't actually fix anything. And under the hood, what actually happens is a thing called Dr. Conky core dump processor runs. This is a rootful service. It's very tiny. All it does is it waits for the journal entry to appear with the crash information. Then it converts it to JSON, because why not? And then it sends it to a user session service called Dr. Conky Launcher, whose sole task is to launch. What is it launching? Well, Dr. Conky. Here we are. And at this point, you get your notification or your crash dialog or whatever. Then the user does his stuff, clicks automatic report, or maybe does the bug report. Then another special behind-the-scenes service comes into play, Dr. Conky Sentry Postman, which is an interesting service because when I clicked submit earlier for the automatic report, it didn't actually send anything. What it did was it created a file on disk that Dr. Conky Sentry Postman then woke up, looked at the file, went, well, this is a submission I haven't done yet, and submits it to the server. This is insofar interesting in that if you disable this service, nothing will ever get sent, which is like the kill switch that you probably thought there needs to be a kill switch, right? Nico, you thought there needs to be a kill switch.
Of course.
Perfect.
Why just one?
Yes, why just, there are actually, like, all of them are kill switches. It's the interesting aspect. But yeah, so if not, then the Sentry Postman sends it off to Sentry, our crash tracker, and then we are done. Great. Everyone on board so far? Cool. Because we are almost at the end. We are recapping what we've learned so far. Crash handling. Well, let the platform be helpful, right? Like in our case, let the kernel do its kernel thing with the core dump file and whatnot, because it makes your life easier. It also means you don't do excessive signal handling, which again means that the racing threads don't come so much into play. And if you need to do signal handling, be quick about it. And then we have the crash reporting. So for crash reporting, if you have an interactive flow, like we had with the Bugzilla thing, then you want to fail early. So that's why we have like 2 stages where you see the backtrace. If you don't get a useful backtrace out of your application, then it would be useless to report. And so we prevent you from going any further at that point. Then you absolutely want to guide the user to actually give you the information that you need. You saw all the questions that it asked me about, is it reproducible, do you remember what you did, which is eventually going to inform, will the report be useful or not, right? And then it needs to be as convenient as possible, if necessary, right? That's where the automatic button comes in. And then on the other side, on the developer side, you want to have good crash collection. A bespoke system like Sentry is really wonderful if you have large-scale applications that you need to track. So I can totally recommend a system like that. There are multiple options. They are all not very good, but you've got to pick your poison. And you can also have a bug tracker. There are also multiple. They are mostly good. But yeah, and you can also combine the 2 systems. So actually, we combine both systems. If you file a manual bug report, you also file an automatic bug report at the same time. So we actually match the 2 data sets up, and within Sentry we then have a link back to the bug report, and from the bug report to Sentry, bridging the gap that way. So here's my recipe for how to crash nicely. You get a segfault handler, you do brief signal handling, you go to the kernel invokes the core dump handler, the core dump handler invokes core dump d. Then it runs the data into journal d. That's the platform concern done, desktop concern comes in. We excavate the core dump, we have the user file at bug report, collect the data, and then ideally at some point you want to recover the application state, right? Like with Plasma, when I crashed Plasma, it appeared again. When I killed Quinn, Ocular was still there and showing the PDF. And I think that is a very important thing, but the most important thing is don't forget to fix the crash. Thank you. Questions? We have lots of time for questions. Yeah.
Looks interesting. I mean, something I always wonder about when I see those automatic reporting systems is if there is any sort of sanitation for possible PII.
Yeah. So the question is if there's any sanitation for personal information, and yes, there is. At the same time, we don't really collect personal information. So like whatever shows up in the backtrace, so there is a chance that something gets in. But at that point, we can also, like, first of all, you can audit this. So if you mask the postman, then you basically can look at the raw data that comes into us. And if you find something that you don't want, you can just delete the file and it will never get submitted.
If I look at the first button option, which is the relevant option, then you would expect that in such cases you have some sort of auto-sanitation, because even if I were to click the second button, should I replace all?
Yeah, right, that's the problem, right? It's a balancing act. And we do obviously do sanitation, but there's limits to it, right? Like,
how would you, is there ways to do it? How would you do that?
I don't know off the top of my head, so we stripped the username, I think, we stripped the machine ID, we stripped the home user path, that sort of thing, yeah.
It's also not a public service on the internet.
Yeah, so the service also is locked down, only KDE developers can access it. So yeah, the idea is if you are willing to surrender some data, then we will do our best to make sure that it's not compromising data, but at the same time you're submitting data, so there's always the risk, right? Yes?
If the system is really non-functional and you wanted to send the core dump, say, to P console, P store or net console or something like that, where would you connect that in the channel?
So this is another reason that you want, or that we architectured this so that it runs through this core dump handler thing, right? because this can run at any point in time. You don't need a GUI for this to run, right? So there's this separation here. There's like, imagine a separating line between the two things, right? And the separating line, you don't need a UI on top, you don't need anything. Then you have the separating line. This could be a reboot, this could be a suspend, this could be a hibernation. So like if you crash on logout, the first part still runs. On login, we can then look through we actually do this. We look through like the last 30 crashes or whatever, and if we haven't yet encountered it, we will actually show you a notification, this has crashed in the past. Do you want to tell us about that? And basically the same thing applies there, right? So whenever, as long as the kernel is functional and systemd is sort of functional, we can receive the crash report.
So you're just looking at varlib systemd core dump? Is that what you do when you log
Kind of, yeah. We look at the journal, so like along with the actual core dump file, it will create a journal entry with lots of metadata, like open file descriptors, which files were mapped, that sort of thing, yeah. And we look at that rather than the file because we need the metadata anyway. Yeah?
So the automatic reporting didn't require any authentication into the service.
Yeah.
Aren't you concerned about some spam entries?
Absolutely. But so the thing is, first of all, there are lots of data pieces to it, right? There was like the version and the hash of the dist ID of the binary and all that stuff. So you would actually have to be very dedicated to manipulate this, but sure, absolutely. And at that point, the only option we have is, so there's like, as part of the URL for submission, there's like a hash ID, and we would basically rotate this. But yeah, it's a problem, but we have to kind of deal with it, I guess, because we want it to be without authentication, right? It needs to be super accessible.
Kind of interesting to see that if you compare the data we get from the old flow and the new flow, the old flow had like a bunch of hoops, you need an account, so the people that made it through tend to write semi-good bug reports. With the automatic one, you can still send some text along, but it's very low entry and you can really see the decrease in quality of the texts you get.
Yeah. Yeah.
What volume of reports are you getting? How many reports do you get per day or per week?
Many. So it's a bit,
Maybe.
yeah, it's a bit diluted because we also record crashes or like issues within the crash system itself. So there's like when the backtracing actually happens through GDB. So we invoke GDB with automation and stuff, and then even load a Python script inside GDB to instrument all the things and extract all the metadata. And that can obviously fail as well. And so we also record those, and those are actually the biggest crashers, so to speak. But yeah, it's actually, we can probably check somewhere.
Should be around 1,000.
All projects. Does it say anywhere? But yeah, so about 25 per hour. Yeah. So this is a day, and it's about peaking at 300 or something, no, 200. Yeah, 1,000 is a good estimate. And that is basically all the KDE stuff, right? So that's like the shell and the apps and the crash reporter itself. We also have some services that are monitored by this, like web services. Yeah.
Can you handle with similar workflow also kernel crashes? Because you can use crash kernel, or sometimes crash message gets stored to pstore and you can recover it after restart. Does it support ingesting
No,
data?
no. I haven't looked into this yet, but It's actually a very interesting point, because what I've done recently is extend this outwards from just KDE software. Because like traditionally we would be interested in our crashes, right? Problem is on the user system, all the other things also crash, and then so I've started creating infrastructure to ingest all data, and so you would get like a tiny notification, this thing has crashed, and then it would get you to this lovely dialog, which gives you the column controller output, and then a way to first of all copy this, so you can file a bug report, and then you can run an interactive debugger, so like GDB actually comes up, and then you have the option to report it as if you have not already reported it, and if we know where to report it. I don't know if I have a Flatpak somewhere.
Get data where to report it.
Oh yeah, so you need to guess, right? That's one of the big pieces why I'm not further with this, is for KDE we know how to and where to. For everyone else it's kind of wild. But so like when the distribution for it, a random distribution application crashes, we usually point the user to the distribution bug tracker as per the OS release file. And when it's Flatpak, we try to figure out if it's FlatHub, and then we send them to the FlatHub repository, that sort of thing. Yeah.
Like we nowadays have all these kind of ELF sections that we embed about like certain bits of information about binary, right? Like for example, the origin of the shared object where it comes from, like the binary. We couldn't theory as something for that.
Yeah, I looked into that, and that is definitely something that we should do. That's like one of the big problems. Like you noticed that there were 2 points in time where we collect additional metadata. First of all, in our K-crash technology, and then by CodeUmpD as well. And it would be good to have like 1 point, and that would be CodeUmpD, but then we need the data somewhere where it can find it. Yeah.
All I'm saying is if you send a patch for the specification,
okay.
then there's
Sure.
where to find the file.
Sounds good. There was a question over here somewhere, I think. Not? Okay.
What do I do if my app crashes not on Linux, but as we learn, we do apps on Android or somewhere else, right?
Yes, but this is the Linux App Summit, so it's a good question. Unsolved issue. But so by making it a platform concern, right? So by delegating the first bit to the platform, you can also leverage that on other platforms. So on Microsoft, you just send it off to Microsoft on Windows, and on Android, you send it to the Google Play Store or wherever.
What if Ocular crashes on GNOME?
Depends if Dr. Conky is installed, right?
Assume it's not installed.
Assume it's not installed, nothing happens, right? But so ideally, GNOME would also have such a lovely workflow and would crash nicely, and then it wouldn't matter that it's a KDE application, right? Because at the end of the day, the user does not care. The user used an application, it crashed, and now we need some handling to happen. And that's also like why we set this on top of CodeUmpD, because I think that's a very solid base to build upon. Yep.
Do you handle cases where there are functioning network, so applications are crashing often, and maybe you could inform the user or the hacker?
Yeah, it's on a very long to-do list. It happens so rarely, and when it happens, there's usually a bigger problem in play than just this application crashing in a loop. Yeah. But for Plasma, for example, I think we just stop if the shell itself keeps crashing and crashing and crashing. We just have like the systemd service go like, you crashed too much, go away, because it's not useful at that point, right? If you have 3 crashes or 16 crashes, makes no difference to the user. It's not functional anymore. Very good. Thank you very much.